good. Okay.
Not sure exactly what happens with the recordings when we go to the telephone. I suspect that some of them may not have the audio. I don't know for sure. So how was your first part of your test yesterday?
Okay. I mean, I didn't freak out or fight out on so we get the results soon. I think after tomorrow.
Okay. So what do you got for tonight?
I think more review. I brought my book in case the packet doesn't.
Okay.
So, okay. Do you think we could go over rules of using radicals really fast?
Sure.
Just because that's usually what I freak out on.
Okay.
Use radicals.
Main rules. I can't think of any other.
Okay.
Now, it's worth knowing that the square root of x is equal to x to the 1/2, and the cube root of x is equal to x to the 1/3, and x to the 2/3 means the cube root of x squared.
Okay.
Come here. I can't think of any other radicals. Maybe the square root of x squared equals x. Do you have some specific problems in mind that we can do, and then we'll apply these rules?
Okay. Let's see if I can find any.
Because usually when it comes to simplifying radicals, those are the only rules I can think of.
Okay. Not really. Not that I can see right now. I'm sure some will come up. I have some simplifying problems.
How about this one here? What's that equal to?
So it's equal to 5 root 2 over root 2.
Okay.
And then those two cancel.
So it's equal to 5. Notice that, yes, that is true, but notice that it's also equal to the square root of 50 divided by 2, which is the square root of 25, which is 5.
Okay.
Okay? You said you had some sample problems or something?
I couldn't find any, like, really just radicals. I just wanted to clarify that. I have some, like, simplifying equations and solving.
Okay.
Alright. So this one says solve the equation, and it says 2x squared minus 4x minus 7 equals 0.
Okay. What kind of problem is this?
The quadratic formula problem?
Well, it's worth giving it a shot as factoring. In other words, either we can factor it or we can plug it into the quadratic. Quadratic assures you of getting the solution. It may or may not factor nicely. We'd have to try it. Right offhand, I don't think it does, because we could try 2x and x, and then we could try plus 7 minus 1. That doesn't do it. Plus 1 minus 7. That doesn't do it. And then we could try minus on this side. Minus 7 plus 1. It's close. That's minus 5x. then obviously this isn't going to work.
Yeah.
So we do have to use the quadratic. Now, can you do this from memory?
The formula?
Well, yeah, or solving it, either one.
Um,
In other words, I had a student last night, and we had this same problem, and he had to look it up on a piece of paper, the quadratic formula. And
oh yeah, I have.
And I said to him, I said, are you going to have to memorize that for tomorrow's test? And he said, yes. And I says, well, then don't look it up now. In other
I have
words,
the quadratic memorized because of that little weasel song from like the
Good.
7th grade.
good. So let's plug it in.
Okay, so it'd be 4 plus or minus the square root of -4 squared minus 2 times, or minus 4 times 2 times -7 over, what's the number, 2 times 2 over 4.
Okay? And the first simplification.
Oh, where's my calculator go?
Okay? You actually don't need one. That is 16 plus 56,
Okay.
which is 72 over 4. Now, let's reduce root 72.
Okay, well, I think 36.
Don't worry. Okay, good, very good. Square root of 36 times square root of 2. What I was going to say is don't worry too much about finding the maximum perfect square factor of that number. In other words, even if I didn't see that it was 36, I could break it down gradually. I could break it down as 4 times 18, and so forth and so on, and then the 18 would be 9 times 2. And so we would eventually arrive at the same solution, which is 6 root 2. Okay?
Alright.
So let's replace that with 6 root 2. And how does your teacher like the solutions? Is that good enough, or do they want it broken down into A plus BI format? Well, in this case, it's not even A plus BI because this is real, but it's an irrational number.
Yeah, I think for sure they'd, you'd have us simplify out the 6 and the 4 and the other 4.
Okay, so this is the way I would state it. I would divide it into 2 fractions, that being one of them, so that's 1, plus or minus this fraction, which is 3 halves root 2. So this would be my preferred notation for the answer. But teachers might be different, so that's why I asked.
Okay.
All right.
Alright, so
Your test is going to cover cubics and quartics and quadratics, right?
I believe so. Something I didn't know before that I learned today is that while the written part of our final was for the honors algebra class, the multiple choice part is for the regular algebra class.
Okay.
So it's not going to cover everything we've learned.
So it's probably not going to cover the harder stuff.
Yeah,
In other words, I doubt that they're going to give you a quadratic disguised as a quartic.
Yeah.
Something like this. In other words, the way we would solve this would be using substitution. You know, u equals x squared, and then turning it into a quadratic of u, and so forth and so on. So, it's better if I let you direct, because you have a much better chance of figuring out what's going to be on your test tomorrow.
Alright, so I'm trying to refine things on the review that gave me some trouble. Oh no. Oh, here. There's a. Oh, what do you do? The dividing thing. I don't remember what it's called. The synthetic division.
Okay.
Here's one of those. So the problem reads 3x to the power of 4 plus 4x cubed plus 12x squared plus 13x minus 4.
And the question reads?
Oh, and then that's all over x plus 4 over 3.
Okay. So how are we going to synthetically divide this? What are we going to put for our coefficients, and what are we going to put in the box?
So your coefficient is going to be negative 4 over 3.
That's what goes in the box.
Yeah. Oh, sorry.
Okay. What are the coefficients across the top?
3, 4, 12, 13, and then negative 4.
Okay. The only thing that's important to remember is that if you were missing one of these powers of x, you would need to put in a dummy variable with a 0 coefficient. In other words, take that out, and I have to replace that with a 0. You have to create a place for every power of x, whether it's there or not. You understand what I'm saying?
Yeah. So okay. If there's no 12x, if there's no x squared variable, you put it in 0.
Right. Okay, I'll point, you read.
Alright, so you bring down the 3, and you multiply it by the 4 over 3, so you get the negative 12 over negative 4. And then you bring that down, and you multiply it by the 4 over 3.
Hold on. When you say bring it down, we add these.
Oh, yeah. So you get a 0 down there, and then you multiply it by the 4 over 3. And then you add that to 12, and then you multiply that by the negative 4 over 3, so that's a negative 12. Negative 16, sorry. And then you add those two, so you get a negative 3, and then multiply that again by the 4 over 3.
And that's the key. That 0 tells you that this divides evenly into that quartic. And what is the answer?
It would be 3x cubed plus 12x minus 3.
Good. Okay.
Let's see. Oh, here's one. If R varies jointly as S and T and inversely as W, and R is equal to 5, when S is equal to 5, T is equal to 4, and W is equal to 2.
Okay, what's my general equation?
Alright, so that would be Z is equal to K.
R?
Oh,
R
sorry, R.
Okay.
R is equal to K times S times T over W.
Okay. And now, which variable are we going to be able to solve for?
K.
Okay. So how?
So you put in a 5, you substitute in all the values. And then you put another 2.
So it looks like K is equal to 1/2. So the specific equation?
Okay, and then it wants you to find R when S is 12, T is 18, and W is 3.
Okay. So what is my specific equation?
So that would be 1/2 times times 12.
First of all, that.
Yeah.
Okay, now we're going to fill in for each of these 3 variables. So it would be 12 times 18 divided by 3.
Would you divide the K by 3 as well? Or just?
No.
Okay.
In other words, this K is 1/2, which is just a constant, so I can completely separate it from the other 3 variables, or I can put that 2 in the denominator. Same thing.
Right.
Now we can do a little bit of canceling. That's 6. Cancel with that 2, so we have R equals 36. And all of these problems are the same. I've yet to see one differently. You have to solve for K as your first step. Once you've solved for K, you can write the specific equation. Once you have the specific equation, when they give you those 3 variables, you can solve for R. They're all pretty much that format.
Right.
Sometimes they might say R is jointly related to S and T and inversely related to the square of W, which would be K times S times T over W squared. So, in other words, it doesn't always have to be linear things over here. Or they might say it's inversely related to the square root of W.
Alright. So then you just alter it as necessary, right? There's no
Whatever they say, yeah, that's what you put. The only thing that matters is what goes in the K is always in the numerator, and the direct is always in the numerator, and the inverse is in the denominator. And that's all you really need to know.
Okay, so there's another one kind of like that.
Okay.
So it says, the electrical resistance in ohms of a wire varies directly as its length and inversely as the square of the diameter.
Okay.
If 96 meters of a wire with a diameter of 2 millimeters has a resistance of 8 ohms, determine the resistance of 150 meters of wire with the same material with a diameter of 5 millimeters.
Do they give you variables, letters to use?
Yeah, it's this little, it's like this weird little Greek symbol, I think.
That's the ohms?
Yeah.
And say again what it's directly related to what?
A wire as a length Okay. The electrical resistance in ohms of a wire varies directly as its length and inversely as the square of the diameter.
Like that. In other words, directly as the length, inversely as the square of the diameter or the diameter squared. Okay, so that's our general formula. And the specifics they give you to allow us to calculate K?
So a wire that's 96 meters long has a diameter of 2 millimeters and a resistance of 8 ohms.
Okay. Do we have to worry about units here? Because this diameter is in millimeters, the wire is in meters.
I don't think so.
Depends on the way they defined it. In other words, if they defined it as directly proportional to the length in meters and inversely proportional to the diameter in millimeters, then we can go with these numbers.
Okay.
You know what? It's not going to matter, is it?
It's not what?
It's not going to matter.
Okay.
The reason it's not going to matter is because this is going to let us calculate K. Now, if everything had to be in millimeters, then K would really have to be 1,000 times bigger. But since we're then going to use whatever K we calculate to come up with a new resistance based on a new length and a new diameter, as long as the new length and diameter are in meters and millimeters, we're fine.
All right.
Okay, so 8 equals 96K divided by 2. So K equals 16 divided by 96, which is 1/6. K equals 1 over 6. So the general formula is ohms are equal to length over 6d squared. Right?
Yeah.
Now, what is the case they ask about? The new case.
So they want to know what happens when you have 150 meters of wire with a diameter of 5 millimeters.
Okay, so they kept everything in the same units. You see why that matters?
Yeah.
In other words, we don't really care that that's in meters and that's in millimeters, as long as the new problem gives it length in meters and diameter in millimeters. If the new problem switched it up on us, we'd have to convert. This K that we came up with is based on the length being in meters and the diameter being in millimeters. Notice that even if I change the length to feet and the diameter to inches, I would have a different K. Wouldn't be the same. So when you calculate a K for a given relationship like this, it's only for those units that were used.
Okay.
Meters, millimeters, and ohms. So this number here looks like 6 over 6. 1. 25 times 6 is 150, so 150 over 150. You see the way I put the 1/6? I just put 6 in the denominator.
All right.
Okay.
Okay. Cool. Okay. Sorry, I'm looking for a problem.
Right. No, I understand.
So, oh here, these are the ones I'm always bad at. So an airplane made a round-trip journey of 4,900 miles. The trip to Boston took 3 hours and 45 minutes, and the return trip took 1.5 hours longer. If the speed of the plane is constant, determine the rate of the jet stream.
Okay. Clearly there was a jet stream, right? If
Yeah.
there was no jet stream, it would be the same time going to Boston as returning. And clearly the jet stream has to be going from Boston to his origination site, because it's taking longer, I'm sorry, the other way around. It takes shorter to fly to Boston than it takes to return, so he must be flying with the wind at his back going to Boston and flying into the wind coming back.
All right.
The round-trip journey is 4,900 miles, so we know exactly how far away he is. How far away is his home?
2,450.
From Boston. So what was his ground speed going from his home to Boston if it took 3 hours and 45 minutes?
Okay.
Distance equals rate times time. So plug it in.
All right. Do you have to convert it to minutes?
Well, probably the easiest thing is to convert that to 3.75 hours.
Okay. So then you have x plus 4, right? Because it would turn.
No, you have distance equals rate times time. So the distance is 2450 equals the rate times 3.75. So divide 2450 by 3.75, what do you get the rate is? The rate to Boston is what?
So 2, 4 is like 6,000 or 653.
Miles,
653, sorry.
miles
Yeah.
per hour. Okay? That was his ground speed. That wasn't his airspeed. That was his ground speed. We covered 2,450 miles in 3 hours and 45 minutes. So the plane relative to the ground went 653 miles per hour. Now let's do the same thing coming back. Got the same mileage. The rate coming back, I'll label R1. And the time is 5.25 hours. So what is his rate returning?
So you take the, would you just make another equation, like 2,450?
Right there. Can you see that?
Where?
The right side of my screen?
Oh, yeah.
Okay.
Where it's the return value?
Yeah.
Okay.
So 2450 divided by 5.25 is what?
Is 466.66.
Okay, so now he went this way at 653 ground speed. He came back exactly the same distance at 466.66 ground speed. I believe that the easiest way to do this from here, find out the average speed, subtract it from one of these numbers, and that will be the wind speed.
Alright, when you say average, do you mean add them and divide by 2?
I do. And notice that's a nice round number. That is 1120. So dividing 1120 by 2 gives us 560. So the average speed was 560. So what does that make the airspeed? The wind speed, actually, or whatever they called it.
So would you subtract it from?
From either one. In other words, if the average airspeed, in other words, this tells us that the airspeed is 93 miles per hour. In other words, I subtracted 653 minus 560 and got 93. 96. And I subtracted 560 minus 466, and I got the same number. I can't do my arithmetic today. It is 3.
93? Yeah.
3 2/3, is it not? No, it's 3 1/3, basically. But that's close enough. So you see how I came up with the 93 miles per hour, and you see how it makes sense. In other words, the airplane speed with no wind at all would be this, 560. But on the way to Boston, it's assisted by a 93 mile per hour tailwind, that's pretty fast wind. That's hurricane size. And you add the 93 to the 560, and so it effectively goes 653 miles per hour. Coming back, it would still go 560 miles per hour if it wasn't into a headwind, but since it is, you got to subtract this 93 off, and it leaves it at 466.66. And I believe that's the easiest way to do these problems. You don't have to use vectors or anything to really solve it, as all you need is D equals RT.
All right. Okay.
There's probably a little cleaner, nicer looking results for that, but I'm 99% sure that that's the correct answer. And a valid way to do it.
Okay. So, the story situations with one variable.
Okay.
Always give me problems too. So.
Okay.
Okay. The length of a rectangle is 5 less than the width. A square can be formed by doubling the length and increasing the width by 10. Determine the value of the width.
Okay. What's the first equation we can write from the very first sentence?
Because these are the ones where you only get one equation.
Okay, that's fine. The first sentence said the length was 5 less than the width?
Yeah.
So what does that mean? As an equation?
So L minus 5.
No, think about it. Put in some numbers. If the length is 5 less than the width, then it has to be length equals W minus 5.
Oh, okay.
Think about, and the reason you know that is because put in some numbers. Let's say the length is 10 and the width is 15. That fits your description. That means the length is 5 less than the width. 10 is 5 less than 15. So if you ever wonder as to whether your equation matches the words, just plug in some numbers and you'll know in an instant.
Okay.
Okay? Now what was the rest of it after that?
A square can be formed by doubling the length and increasing the width by 10.
Okay. So this is the original length. That's the original width. And they're saying that if we double the length, it's going to be equal to increasing the width by 10. And the reason I say equal is because that's the only way you'll have a square, is if the new length is equal to the new width.
Okay.
Now, it looks like we have two variables and two equations, but these can be solved pretty easily by substitution. What's my next step? There's one equation. There's another one. Now, you said this was a single variable equation.
Yeah.
But I don't think so. I mean, I guess, okay, a single variable equation would mean that you have width and you have width plus, or you have width plus 5, which is the length. Right? In other words, if I solve that equation for width, I get L plus 5. So width is, the length is equal to W minus 5. So there's my width, there's my length. So, okay, so I don't need two variables. I personally think it's more understandable with two variables, but if you are only limited to one variable, well, instead of 2L, I'm going to say 2W minus 5. Now we have the whole thing in one variable.
Okay. Okay.
Okay, do you see why it's actually easier in two variables? It's completely understandable in two variables. I prefer this problem much better in two variables. I mean, I don't know how she can force you to use one variable. If we use two variables, it's very simply that, and then we're going to solve this equation by substitution. Instead of L, we're going to substitute W minus 5. So we're going to get there in one more step, and we're going to understand much better what we're doing.
Yeah, I know that's definitely one place I missed points on the final, was because he wanted us to use one equation, and I used two. Because I couldn't figure out how to do it with one variable, so I just kind of like...
Well, okay, let's go back and see how we did it as two variables. Well, instead of saying the length is W minus 5, he's going to label this rectangle as W minus 5 like that. And we're never going to see that equation. So if we never see that equation, then we go directly from this to this. This was the length, W minus 5. The width was W. And he's saying a square can be made if we double the length and add 10 to the width. So here's doubling the length, and it's going to equal adding 10. Might be off there. Well, because if I add 10 to the width, it's just W plus 10. There's no minus 5 on this other side. This is it. Ooh. Does that work? Let's see. We get 2W minus 10 equals W plus 10. Move that W over. We get W equals 20. So if W equals 20, the length equals 15. So we started with a rectangle that was a 15 length, a 20 width. And they're saying that if we double the length to 30, that will equal the width plus 10. So I did write it wrong the first time. In other words, it was 2 times this length equals the width plus 10. But I didn't make the mistake because I was in 2 variables. I made the mistake because I just wasn't paying enough attention to it. Making the mistake on the right side of the equation had nothing to do with whether I used L here or W minus 5.
Right.
Okay. But on a problem like that, once you get the answer, be sure, if you have time, go back and check it. Because it's pretty easy to check, as you saw. In other words, make sure when you come up with the solutions that it now fits the word problem.
All right. Okay. Okay, here's another single variable problem.
Okay.
Your nephew's piggy bank contains dimes, nickels, and quarters. He has 2 times more dimes than quarters. He has 16 fewer quarters than nickels. Determine how many quarters are in his bank if the value is $13.70.
Okay. What I'm going to suggest to you is that you personally use 3 variables and then switch it to a 1 variable equation. It's silly to try to solve this problem in 1 variable from the get-go. So the first statement said what? Dimes and nickels, or dimes versus quarters?
He has dimes, nickels, and quarters.
What's the relationship between dimes and quarters?
He has 2 times more dimes than quarters.
So dimes equals 2Q. What's the second statement?
He has 16 fewer quarters than nickels.
So nickels are 16 fewer than quarters, right?
Yeah.
Which means if he had 20 quarters, he would have 4 nickels.
Yeah.
Okay. Now the third thing, how much money does he have?
$13.70.
If we use 3 variables, the number of nickels is multiplied. What equation if I want to use 3 variables here?
Well, you would have...
How much money in nickels does he have? First of all, nickels is, N is equal to the number of nickels. D is the number of dimes, and Q is the number of quarters. And coin problems are quite common, so you need to know how to convert this to an amount of money. How much in nickels does he have?
He has 16 minus Q is equal to N.
Well, with our original 3 variables, this is just going to make it confusing if we try to start out in 1 variable. Let's start out in 3 variables. The number of nickels you have in your pocket times 5 cents is equal to the value of those nickels, right?
Yeah.
Plus the number of dimes times 10 cents gives you the value of your dimes, plus the number of quarters times 25 cents gives you the value of your quarters. So there's our master formula. Now, he wants it in one variable. Okay, wherever we see n, we're going to use q minus 16, and wherever we see d, we're going to use 2q.
Okay.
So it becomes 0.05 times q minus 16 plus 0.1 times 2q plus 0.25q equals 13.7. Now that allows you to solve for the number of quarters you have. Once you get the number of quarters, you'll know how many dimes. Once you get the number of quarters, you'll know how many nickels also.
Okay.
Okay? Now, I don't see the value of skipping this step right there. In fact, that step is very important to understand this problem. The way you calculate value when you have a pocket full of coins is to multiply your nickels by 0.05, your dimes by 0.1, and your quarters by 0.25, add them all up.
Right.
The fact that we can define nickels in terms of quarters is perfectly fine, but we don't need to do it as an invisible step. And we can define dimes in terms of quarters. So we'll get to this step right away, but I think it's asking a little much to ask the students to go to that step immediately. And I don't know that he necessarily is. He says he wants it as a one variable equation, so fine, so only show him that. On your scratch paper, do that one, and these two up here. And eventually you're going to need these two anyway to convert, to know how many dimes you have. You have to write out that equation, because even the single variable equation is only going to solve for q. So you're going to have to go back to this equation to solve for d and this equation to solve for n. Or does it only ask how many quarters he has?
It wants to know how many quarters are in his bank.
Oh, and that's it?
Yeah.
Okay. So all we have to do is solve that, and we'll have the answer. We don't have to go back and find out how many dimes he has and how many nickels he has. But the crux of this problem, this is a very common problem in algebra, and I think it's a mistake to ignore the three variables from the beginning. Okay? You don't have to show them if you think you're going to lose points for it. You can just start right off with that equation right there, the bottom equation. If you're capable of doing that, just do that on your test in terms of showing your work. But I don't like it, but okay.
All right. Here, another one. So the length of the base of an isosceles triangle is 1/4 the length of each leg.
Right?
Determine the possible lengths of each leg if the base must be an integer and the perimeter is at least 46 centimeters and no more than 80 centimeters.
And you have multiple choice, and there's various answers in the multiple choice.
Yeah.
I have another student that had the same problem, and he sent it to me on paper. So this is kind of a back-solving problem. The first answer doesn't make any sense at all, right?
No.
What's the second answer? B?
24 centimeters, 28 centimeters, 32 centimeters, and 36 centimeters.
So those are perimeters, right?
Yeah.
So the question is can each of these numbers be a possible perimeter? Well, the perimeter is 9/4 x. Can 9/4 x equal 24 and have x be a integer?
No. right?
What's the answer on C?
24, 28, and 32.
And these are possible perimeters, right?
Yeah.
And x has to be an integer?
Yeah.
Oh, 24 is possible
Yeah.
because x would be, I was doing the math wrong, 96 divided by 9. That's not an integer.
Where did you get 9 for?
Because 2.5 or 2 1/4 x is the perimeter.
Okay.
In other words, it's an isosceles triangle, so that side's equal to that side. And they said the base was 1/4 of one of the sides, right?
Yeah.
So 9/4 x would equal the perimeter. X plus 1/4 x. So could the perimeter be 24? Well, that would make 9x equal to 96. That's not divisible by 96. I'm making a mistake here because when I did this yesterday, 24 is a possible answer. The 30, what's D?
20, 24, 28, 32, and 36.
And A was like 6, 7, and 8 or something.
Yeah, 6, 7, 8.
So clearly 24 works. What am I doing wrong here? 9 does not divide into 96 evenly. "28 works also. Why does 28 work? 4 times 28 is 112. 9 doesn't divide into that evenly either.
Huh.
One moment.
Maybe it's a...
One moment. I'm doing something wrong here. Well, this is scary because I did this problem yesterday. Why does 24 work? Well, 24, these are possible values for x or possible values for the perimeter? These are possible values for x, I believe.
Okay. So that means that 24 has to be 1/4 of...
Well, it means 24 would work because we would have 24, 24, and 6. And that's 48, 54, which is between those two values.
Oh, okay, so it's not...
20 does not work. If we make it 20, 20, and 5, we have a perimeter of 45, which is less than that range. So 20 doesn't work. 24 works. 28 is 28, 28, and 7. That works. So that works. That works. 32 works because it's 32, 32, and 8, which adds to 72.
So then the answer must be 6. Or C.
C,
Sorry.
it is. 24, 28, and 32. 36 doesn't work because that would be 36 there, 36 there, and 9, and that would give you 81 perimeter. Yeah, I'm sorry. These values were for x. That problem was hard to understand by looking at it and reading it. Yeah. Very, very hard to understand. It took him and I 5 minutes to figure out what the heck they were asking for. And then I forgot it between yesterday and today. So.
All right. Well, thank you.
You're welcome, and very good luck to you on your test, and have a nice holidays. And let's see, should we talk about when the next session's going to be?
Yeah, let me look up my...
You get back on January 6th from school, I believe?
Yeah.
So you want to have a session that Wednesday on the 8th? Or will you need one?
I'm guessing so, because we'll probably be learning new things by then.
Okay, so you and David, you want to go back on the regular schedule? I have you down for that Monday. You won't want that one, I don't think. So I will put you in starting on the 8th on Wednesday, both of you. And then we can talk on that Wednesday as to whether you need another one per week.
All right.
Okay?
Sweet, thank you.
All right, enjoy your vacation.
Thanks, you too.
Bye-bye.